All right, function is y equals tangent 2 theta plus pi plus 1. Great? Okay. Now, Mr. Dietz, what is a parent graph? Okay, Mr. Walgo, what's the parent graph?
Okay, the parent graph is like you start at 0.
No. What is the parent graph? Just what do we call it?
It's just tangent theta.
We're going to graph y equals tangent theta first, right? That's what we mean by parent graph. All right. Mr. Dietz. I'm going to slide from left to right. What happens here?
That's period.
Period. And the period formula is what?
It is 2 pi over k.
Very well done. Mr. Welko, can you correct that for him?
No, it's correct.
That's incorrect.
Oh, wait.
For a tangent graph, it is pi over k. For a tangent graph, it's pi over k, because tangent repeats every pi.
That's the period?
That's the period
Okay, wait,
formula.
That you just said.
So the period formula for a tangent, because it repeats every pi instead of every 2 pi, Mr. Dietz, you with me?
Yes, sir.
It's going to be pi over k, not 2 pi, because it repeats every pi. So I'm going to put that in my formula. I get pi over 2. Agreed? All right. Pausing there. We good? Okay. So you thought Welko would be the perfect person to phone. He didn't have it. Maybe we'll have the next part. Phase shift.
Okay. Is the phase shift formula different?
No, it's the same. So what I get?
Pi over 2.
Pi over 2. What else you got for me?
The plus 1 is going to be an upward shift.
Shift up 1, right? Okay, so part of my point in making you do this is very familiar. The only thing that's a little different is that the period, right? And that paragraph's going to be different. Our starting point's going to be different, right? Okay. And so I'm going to ask Welko right now, what does the starting graph look like? Help me out.
Well, like,
How do you describe it? I don't even know.
it's like
My
a bunch
bad.
of S's, like a bunch of super long S's in a row.
It's a grizzly bear scratch.
So what happens is every pi over 2 and negative pi over 2, this graph becomes asymptotic. It's undefined, right? If you look at 90 degrees or pi over 2, it is undefined. Can't have a point there. It has a point at 0. It has a point at pi over 4, 1, all right? 45 degrees, opposite of adjacent are the same, so it gives you 1. But after that, it does something freakishly wrong. It goes, woo, up like that. Now I'm going to undo that in a moment because that's not our final graph, right? So I should be doing dashes. Agreed?
Why is there a point at pi over 4?
Sorry, one more time.
Why is there a point at pi over 4?
At pi over 4, 1, because the tangent of pi over 4 is in fact 1.
Oh, okay.
Okay? So that's a point we're gonna focus on. And then we know it suddenly becomes, and then once you cross the undefined line, it suddenly becomes negative. Right? Because all sick Tanzanians and Canadians. So S is positive, so tangent is negative, right? So it goes suddenly, at this point, it suddenly goes from positive to negative. The only way to deal with that and have a thing is to have it come in like this. Right? We also know, by the way, it's at -1 at that. So that is what the tangent graph looks like. The parent graph, the original. This is one full phase. Notice it would repeat after this by going up like this. Agreed?
But that middle line is always going to be dashed.
Yes. That was going to be dashed for eternity because it's an asymptote.
Right. Okay.
Right? That's just guidance. All right. Yes, sir?
On our final graphs, do we need to put the asymptote dashed line?
I don't have to see any asymptotes at all, but it is in your best interest to give me an asymptotes. That's the number one way I'm going to check to see if you did your period right. And if those are messed up, you're dead. And I'll tell you this. A lot of people will tend to draw like this. I'll see this. They'll see it like this. And then this one starts over here and goes like this. That's a stop. Right? Because they don't have the dashed line, they just kind of go like this. It's like, no, they're over the same spot. That I have to ding you for. Okay? All right. Happy trails? All right. What?
The other point is at pi.
At pi is when we reach this back to 0. Okay? All right. Now that we've got that, and we've got the tangent fixed, we've got the parent graph done, the rest of it's just like we were doing before. Okay, so we're going to start here. What's our period? So that means I got to do this whole entire thing by pi over 2, which means this thing's going to suddenly become much more congested, right? I've got to go all the way up, asymptote, and then all the way in by pi over 2. Right? And take this graph, and I'm going to go to it. Yes, ma'am?
Have you applied your phase shift yet?
Not yet. I'm doing step at a time. In my period?
Wait, do the period again, please.
Okay. I was at pi, right?
Yeah.
Okay. Now I've got to do it by pi over 2. So I got to do this up, starting over again, into here, but I got to stop by there. So I'm going to go up, back into here.
And
Right.
you're just like eyeballing?
Sorta.
Because where's the
Right? Because we know the line's halfway between they're in the starting line, right? So I put a dashed line through the middle. I know I'm going to infinity. I know I'm coming back from negative infinity to 0. But you do bring up an interesting point. How does amplitude affect this graph? It stretches it, right? So you get to 3 times infinity, or 4 times infinity, or a half times infinity. What's a half times infinity? Infinity. So therefore, how does an amplitude affect the graph? Not at all. If I put one in front of there, it's just to mess with you. It does not affect your graph at all. If I put 3 tangent, you'd be like, okay, whatever. I'm going to reach 3 times infinity. Ah, ha, ha. What? You have to flip it. That you have to do. You have to flip it this way, right? So it'd go down, then in, right? What's up's down, what's down's up. Okay, so I'm going to do a phase shift. So I'm going to phase shift this, pi over 2 to the left. So this point's got to go pi over 2 to the left. Any different colors. Do this one. That point's going to be there. This is going to move over here, which is an asymptote. Right? And then I got to bring it home. So I'm going to go, and this point here's on my graph, right? Because I'm bringing this one right to here. So I'm going to go up, and then like this. See how icky these get, especially if you like use a pen. What? Yes.
one more time, please?
Oh, they asked me to phase shift it pi over 2, right? Since it's positive, I go the opposite way I expect to go, right? So it's to the left, pi over 2. So I took this point, and I moved it pi over 2 to the left. I took the asymptote, moved it pi over 2 to the left. I took this point at the end, moved it pi over 2 to the left. There's drew it. Mr. Dietz, H equals 1. Up 1. So I'm going to take all these points that I know of, and I'm going to move them up 1. Let me, what should I do? Ooh, let's do this. Hold on. Let's go glowy. Does that work? No, it's not glowy enough. Hold on. Glowy. Let's do glowy. Ah, this doesn't help me at all. All right, whatever. Here we go. So I'm going to lift it up by 1. So this point here goes in. This is still an asymptote, right?
Yeah.
This point goes here. How do you move an asymptote up 1? It doesn't go up 1. So now I'm going to go, woo! I'm going to go, woo! Now, once I've done this, how do I finish up my graph? Repeat the pattern, right? So I'm going to do this now. Asymptote. Bring it back in. Go on up. Bring it back in. Go down. Go down. And I'm done. Tangent graph. Yes, ma'am.
So could you say that if the phase shift was any multiple pi over 2, there's actually a phase shift?
Right. If you phase shift to the same thing as a period, you're just moving it one full way, one way or the other, which is a waste of time. Right? Because we ran it down, we did 16 pi with a phase shift to 16 of pi. It's like, okay, woo, move it one phase to the left. What are we doing here? Waste of time. Yes, ma'am.
I feel like I think you already answered this, but for amplitude,
Yes.
since I think you said it doesn't matter.
It's
Because
for our purposes, it's not going to matter.
But wouldn't you have to move up pi over 4?
No. Amplitude is how rapidly it goes. Well, yes. Is that what you're saying?
Yeah.
Instead of 1, it should be 3 or 4. Yes.
Yeah.
Should.
Okay.
Absolutely should. But again, I'm not even going to be for sure that you're going to actually try to go through one, right? You're going to be drawing these graphs. And so me checking to see if you did 4 times the one that you didn't even bother to do makes this much more difficult. In addition to that, remember that tangent graphs, we haven't done many of them. We're not going to do many of them. Why? Nope. What is this model? Got me. Now, what goes to infinity that suddenly appears at negative infinity, goes through the middle, and then goes back to positive infinity again?
Buzz Lightyear.
Buzz Lightyear, yes, that's exactly what it involves. Buzz Lightyear's video game, maybe. Literally, asteroids is what I always think of. You go off one end of the board, you appear on the other end of the board.
Asteroids?
Yeah, you don't know what that game is. It was a game back
Oh,
when I was
no,
a kid.
I do know what it is.
Kid, little rocks,
Yeah.
made a noise, boom, 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 boom. And you try to shoot the rocks, and then when you shot the rocks, the game made more rocks, which really kind of frustrated you. Yeah. Yes. Or no, sorry, Erickson.
Do you have to end these graphs with the one on the top and the one on the bottom?
No, you have to fill up the graph paper, right? So since I ended at pi, this one here has to be there. This has to be here because that's where it ends at pi. Okay? Now, I'll be frank with you. When I give you a piece of graph paper, if you go off my graph paper extra, because you kind of need to feel like you need to do that because you want to look at what it's doing, cool. I'm going to graph what's on my graph paper, right? That's what I look at. That's what I get to grade. Even if it's wrong off my graph paper, I want to do it. Was that fun?
I know.
It's about to get worse, so if this isn't fun, you're going to really not like what's coming. Yes, ma'am.
Okay, can you? I'm not good at this.
Now just fill
How
out.
do I make it? How do I do that?
This is the next part of the graph, right? So you do that part, so you asymptote, and then you're going to do this part.
How do I know what the axle is?
Well, get an asymptote here, right? Get an asymptote in the middle, right? Okay. You know you got to graph this before you get to the next asymptote, right? So you just repeat this pattern. You go like this, up, and drop, and repeat.
Like that, that you plug in.
Exactly, and that's an asymptote. So draw the asymptote down. Yes, sir. Probably not.
So just do tangent first and
It's
then
Okay, so tangent, whatever tangent, so where's tangent undefined?
What?
There's 2 places, right? How do you write the answer? Equals pi over 2, a bunch of it's true, plus, it repeats every pi, right? So plus pi n, plus pi n, where n is equal to dot 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 negative 1 0 1 2 dot dot dot. Good? Sort of? Let me do that real fast, but okay, so I see some of you are already working on number 10. Stop it, put your pencils down. We haven't talked about number 10 yet.
Good.
All right, I got some work to do. So the next thing I want to teach you how to do is I want to teach you how to do cotangent graphs. Oh yeah, cotangent graphs. So, oh no, we're at 14 minutes.